So problem number 2, design limit gauges. So for a shaft of 30 mm, the chosen fit is H7C8. We have to design a go and no go gauge. The diameter steps are given for this problem, otherwise we have to take it from the table, standard table, from the design data book. The fundamental deviation for S type of hole is 0, it is given. Okay, so the very first step is to find out the diameter steps. So since the diameter step are given as 30 to 50, therefore we have to calculate D. So D is equal to under root of 30 into 50, it comes to be 38.73 mm. Okay, now the value of fundamental tolerance unit I we have to calculate. So we know that from this table the fundamental tolerance unit, it comes to be I is equal to 0.45 third root of D plus 0.001 D. Okay, so we have to take this formula. Therefore fundamental tolerance unit I is equal to 0.45 third root of D plus 0.001 D. It comes to be 1.561 microns. That value comes to be in micron. We have to convert it to mm. So it comes to be 0.00156 mm. Okay. Now the third step, as we know, the fundamental deviation for H type of hole is 0. Is 0. So what is this fundamental deviation? Fundamental deviation means if this is the basic size, if this is the hole, this is the shaft, so this difference is known as fundamental deviation. So for hole it is 0. So therefore minimum size of hole, that is phi minimum for hole, it comes to be equal to basic size. In this case the basic size is 30 mm, right? So it comes to be 30 mm. So fundamental deviation is to be calculated or is to be find out from this figure. For S type of shaft the fundamental deviation is 0 because the lower limit is on the 0 line. So the lower limit or minimum size of the hole is equal to the basic size. Okay. So now to calculate the maximum size of the hole, we are in need of the tolerance. So For maximum size of hole, we have to calculate the fundamental tolerance for hole. Okay, so we know that for H type of hole, with IT grade 7, that is IT7, okay, is for H7. IT7 is equal to, so again from this formula, IT7 is 69, so 16I, it comes to be 0.02496 mm. So this is the tolerance for hole. This is hole tolerance, right? So therefore maximum size of hole is equal, that is phi maximum for hole, that is equal to basic size plus tolerance. So it comes to be 30 plus this 0.02496, it comes to be 30.0249 mm. So this is the phi maximum for hole, or maximum size of hole. So we can draw the figure like this. This is basic size, so this is lower limit, this is upper limit, this is tolerance for hole. Okay, so tolerance comes to be this one, this is the tolerance, this is the phi maximum, and this will be the phi minimum for hole. Okay. So for C type of shaft, so now for C type of shaft, we have to calculate the fundamental deviation. So fundamental deviation for C type of shaft, it is, we have to calculate from this figure and from this table. So for C type of shaft, the fundamental deviation is this one, minus 95 plus point, this is 0.8 D. Okay, so from this table the formula is minus 95 plus 0.8 D. It comes in microns, so put the values. So it comes to be that is minus 125.98 microns. So that is equal to minus 0.125 mm. Okay. So therefore fundamental tolerance for C type of shaft with IT grade is given as 8, IT8. For C8 C8 shaft is there, so C8 IT grade 8, so IT8 from this table, so IT8 is 25I, so that is 25I, it comes to be 0.039 mm. Okay, so now calculate the maximum size of shaft. Maximum size of shaft, that is phi maximum for shaft, it comes to be basic size plus fundamental deviation. So basic size is 30 minus fundamental deviation is 125, it comes to be 29.874 mm. Then minimum size of shaft, that is phi minimum for shaft, it comes to be phi maximum, because if you want to draw suppose this is a basic size and this is the shaft, okay, and this is the tolerance. Here you can have hole, okay, so this difference is known as fundamental deviation for shaft, and this difference is known as tolerance. So this is phi maximum or upper limit, and this is phi minimum or lower limit. So phi maximum, if you want to calculate the phi maximum, we have to, this is the basic size, so minimum size, maximum we have calculated, basic size minus fundamental tolerance, we get the maximum phi. If you want to calculate minimum phi, just we have to reduce phi maximum minus tolerance. So phi maximum is 29.874 minus tolerance, tolerance is 0.039, okay, this is the tolerance for shaft, so it comes to be 29.835 m. Okay, now we have to calculate the gauge tolerance and wear allowance. Okay, step number 5, gauge tolerance and wear allowance. So gauge tolerance for hole, gauge tolerance for hole is taken as 10% of fundamental tolerance for hole. So 10% of the fundamental tolerance for hole is 0.02496, and that is 10% of 0.02496. So 2496 we can, 10% of this means 0.002, will take rationally to 0.246, will take 2.5 225. Okay, so again wear allowance for hole, wear allowance for hole is 10% of gauge tolerance, 10% of this value, so it comes to be 0.0010225 m. Okay. Then similarly gauge tolerance for shaft, gauge tolerance for shaft is 10% of fundamental tolerance, it comes to be 0.0039 mm, and wear allowance for shaft, it is 10% of gauge tolerance, so it comes to be 0.0003 mm. Now we draw a figure. So we'll draw a figure. Okay, so this is the figure for tolerances and allowances or fundamental deviation for shaft and hole. Okay, so this is phi maximum, this is phi minimum for hole. Okay, this is phi maximum and this is phi minimum for shaft. This is IT7 and this is IT8. So you can assume that all this is the tolerance zone for hole as well as for shaft, right? These are the tolerance zone. So this is the basic size, that is 30 mm. Okay, this is no go gauge, this is go gauge. This difference is gauge tolerance and this difference is wear allowance. Okay, this is gauge tolerance. Okay, similarly, yes, and this is the fundamental deviation. This is the fundamental deviation for shaft, that is minus 0.1259 mm, right? So this is the go gauge and this is the no go gauge for shaft. So here this is the gauge tolerance, okay, and this is the wear allowance, right? This is the gauge tolerance, this is the wear allowance. So these are the values. This is 30.024 and we have already calculated all this. This is 29.874, this is 29.835. so we have all calculated maximum phi for hole, minimum size of hole, this is maximum size of shaft, this is minimum size of shaft, these are the fundamental deviation, these are the tolerance. Okay, this is the tolerance for hole and this is the tolerance for shaft. Okay, so calculate for hole. We have to calculate the dimensions for go gauge So in this case it comes to be basic size for go gauge, it is 30. So maximum it goes up to uh, wear allowance plus gauge tolerance, and minimum up to wear allowance. So plus gauge tolerance plus wear allowance, and in the minimum it goes up to, so it goes up to the maximum size of the go gauge is up to here, okay, and minimum size will be up to here. So for maximum wear allowance plus gauge tolerance on above this 30 mm, and minimum above this 30 mm wear allowance, okay. So input the values, you can find the answer. And for no go gauge, for no go gauge, the basic size is 30.0249, okay. So up to maximum value for this no go gauge is this plus this gauge tolerance, and minimum is equal to this 30. So plus gauge tolerance plus 0.00. Okay. Similarly for hole, for shaft. Similarly for shaft, the value for go gauge, it comes to be this 29.874, and so two values you can get. This is the minimum value and this is the maximum value. So minus wear allowance plus gauge tolerance, right? Similarly no go gauge, the value is 29.835. so it may be up to -00, or we have to add the gauge tolerance. So these are the values for the gauge, limit gauges designed for checking hole and shaft, the go and no go values. Thank you.